Please, shall we all rise to honor the procession?
It's lovely, Ladoke. You've kept the promise. Now we're singing, all dressed in splendor, as your promise again is kept. Oh, dear sweet rainbow, allure my feelings, make it so timeless. One race for zenith, we together began one day. You led me on as we've come this far. We feel
Nigeria, we hail thee, our own dear native land. Though tribe and tongue may differ, in brotherhood we stand. Nigerians old and proud to serve our sovereign fatherland.
Please, let's be seated. On behalf of the Faculty of Pure and Applied Sciences of the Ladoke Akintola University of Technology, Ogbomoso, I want to welcome us to the faculty lecture, 11th in the series, with the topic Imaging the Surface Earth, the strategic role of geophysics in prospect, evaluation of natural resources, and sustainable national development, to be delivered by an erudite scholar, a professor. A professor of applied geophysics, Professor OYELOWO BAYOWA. But before we start anything, thank you very much. Thank you very much. Let me quickly introduce to us dignitaries in our midst, especially people on the high table, though they are not sitting on the high table today. So let me quickly run through their names. Now, for today's program, we have the Vice Chancellor of this great university, Professor Razak Olatunde Romka-Lilu, ably represented today by the Dean Faculty of Art and Social Sciences. Please join me in welcoming Professor Frank Ebijua. Thank you very much, sir. We appreciate you. We also have in our midst the Deputy Vice Chancellor, Strategy and Development, Professor Tunde Ogunkunle, in our midst today. Thank you very much, sir. We appreciate you. We also have the University Librarian, Professor Adefunke Sarah Ebijua. Thank you, ma'am, for coming. Then we also have the Dean, Faculty of Pure and Applied Sciences, Professor Michael Olusope Alade, FNIP. Thank you very much, sir. We appreciate you. And the last person on the high table, let me call it on the high table, is our lecturer today, Professor OYELOWO BAYOWA. Thank you very much, sir. You are welcome. So because of our time, we are going to suspend all other introductions. So we are very sorry for this. It's because of our time. So let me quickly invite the Dean of the faculty, Professor Olusope Alade, to do three things. First is speech, and he's going to declare the program open before reading the citation of the lecturer. You are welcome, sir.
Good afternoon, everyone. Welcome address delivered by the Dean, Faculty of Pure and Applied Sciences, at the 11th Fpas lecture series today, June 9, 2026, at the Hall, Ladoke, Ogbomoso. Protocol. The Vice Chancellor, ably represented by Professor Temisan Ebijua, the Dean, Faculty of Art and Social Sciences, the University Registrar, the University Bossa, in absentia, the University Librarian, Professor Ebijua, you are welcome, ma. The Provost of Colleges, the Deputy Dean, Faculty of Pure and Applied Sciences, the Dean, Postgraduate School, all other deans of the faculties, other faculties, Head of Department of Faculty of Pure and Applied Sciences, professors, technical and administrative staff, all other invited guests, great Ladokites, great Nigerian students, ladies and gentlemen, it is my pleasure to warmly welcome you all to the 11th Fpas lecture series, which is the 4th lecture series to be held since I assumed office as the Dean of this great faculty. The 8th Fpas lecture series, which was the first under my leadership as the Dean, features a lecture titled Paradoxical Creatures Insect as Paradigm, and was delivered by the Professor of Biology, Professor Ibamiji Oyewole of Department of Pen Applied Biology. The 9th Fpas lecture series, the second during my tenure, featured the lecture titled Environmental Toxicants, the Unseen, the Unavoidable, the Unforgiven Threat to Life, delivered by another erudite professor, Olusegun Kayode Afolabi of Department of Biochemistry. The 10th Fpas lecture series, the third under my administration, featured the lecture titled Valorization of Agricultural Waste, a Resource for Environmental Remediation and Waste Reduction, delivered by Professor Olugbemiga Solomon Bello of the Department of Pen and Applied Chemistry. Today, we are gathered for the 11th Fpas lecture series, the fourth under my leadership as the Dean of the Faculty. The lecture will be delivered by a distinguished Professor of Applied Geophysics, Professor OYELOWO BAYOWA, and the current Head of the Department of Earth Sciences. The title of his lecture is Imaging the Subsurface Earth, the Strategic Role of Geophysics in Prospect Evaluation of Natural Resources and Sustainable National Development. It will not be an overstatement to say that there is no better time for this lecture than now, when Nigeria is facing significant economic challenges and seeking sustainable ways of generating revenues to drive national development. There is no doubt that this lecture will serve as an eye-opener to the vast and hidden treasures beneath the Earth's surface and the strategic role that geophysicists can play in unlocking them for national prosperity. The 12th Fpas lecture series will be delivered by another distinguished professor from the Department of Pen and Applied Mathematics. One of the major achievements of this administration in the faculty is that the procedure for Fpas lecture series presentation was reviewed immediately after I assumed office as the Dean.
which contain organic matter, mineral water, and microorganisms, which are important for agriculture and ecosystem support. Rock layers, which include sedimentary rocks, that is sandstone, limestone, shale, siltstone, clay, and so on. Igneous rocks, granite, syenite, diorite, dolerite, gabbro, basalt, dunite, and so on. Metamorphic rocks, gneiss, schist, calcite, marble, slate, to mention but a few. The last two above are known as crystalline basement rocks. Subsurface groundwater system, figure 3. The subsurface water system can be divided into two zones. One, zone of aeration, and two, zone of complete saturation. The zone of aeration, this is the space between the ground surface and the water table. Contains soil water, capillary water zone, and pellicular water zone, whose soil pores are partially water filled. In the zone of complete saturation, or what is known as groundwater zones, water is stored below the water table in pore spaces of sediment and fractures in rocks known as aquifers. Groundwater is a major source for drinking water, irrigation, domestic and industrial usages. Scientists study the Earth's subsurface to understand the structure, composition, and geological processes occurring beneath the ground. Yet, the discovery, characterization, and sustainable management of the natural resources requires sophisticated scientific approaches grounded in earth science and geophysical innovations through subsurface imaging. In geophysical context, imaging refers to the creation of picture of the subsurface earth using geophysical data. Geophysical methods such as seismics, electrical, magnetic, and gravity are used to map underground structures as contained in figure 4, which are important in natural resource prospect evaluation. Why do we need to image the subsurface earth? The subsurface earth is inherently large and inaccessible. Direct sampling through mechanical drilling is very expensive and limited in spatial coverage. The Earth's subsurface cannot therefore be directly observed. This makes an indirect sensing through geophysics crucial. The primary objective of subsurface imaging include identification and mapping of geological structures, that is faults, joints, fractures, dikes, cavities, etc. Characterization of subsurface lithologies, that is rock units and their physical properties. Assessment of distribution and quantity reserves of solids, minerals, hydrocarbon, and groundwater resources. Provision of information for support infrastructure development and hazard assessment. Facilitation of sustainable environmental and resource management through real and actionable database. The fundamental of geophysical imaging. Geophysics is the art and science of imaging the invisible subsurface in order to be able to unravel the hidden structure that holds the natural resources beneath our feet. Geophysics provides the tool to detect, delineate, quantify, model, and predict through data acquisition in the air, which we call airborne, on water, which is referred to as marine, or on the hard surface, which is ground survey, without destructive excavation of the earth. It applies physical principles to characterize the subsurface from crustal structures to deep reservoirs, enable us to discover and extract natural resources while minimizing environmental impacts. Geophysical imaging produces spatial representation, that is, models from physical property radiation within the Earth's surface. This is contained in Table 1. The physical properties include magnetic susceptibility, seismic velocity or acoustic impedance, stroke elasticity, density, electrical resistivity or conductivity, dielectric constant. These are the intrinsic properties of the Earth's material, that is rock, minerals, and etc. that different geophysical method measures. Table 1 here shows the geophysical method, their primary use, and the intrinsic property of earth materials that they may sense. Each of these methods has its strength, depth of investigation, resolution, and limitation. Hence, there could be the need to integrate two or more of this geophysical method with the knowledge of geology to provide predictive exploration models. Prospects and prospect evaluation of natural resources. The term prospect, resource, and reserve are related. A prospect is a geological or geochemical or geophysical anomalous area or target with sufficient evidence to justify a detailed follow-up exploration and evaluation for economic extraction. When a prospect has been explored in considerable detail, is close to the development or production stage, but not yet confirmed as a commercial deposit, it becomes a resource. However, the transformation from resource to reserve requires reliable subsurface imaging and accurate volumetric estimation. Without robust geophysical modeling integrated with limited drilling, reserve estimation remains at best speculative. A mineral prospect, for example, may be defined by 1. Alteration zone, 2. Vein system, 3. Geophysical anomalies, and 4. Surface mineralization. Whereas a petroleum prospect may involve structural trap, that is anticlines or faults, or stratigraphic trap, or seismic amplitude anomalies. While a groundwater prospect may be characterized by weathered or fractured basement zones, high transmissivity sedimentary aquifers, and resistivity anomalies. Prospect evaluation, on the other hand, is the systematic process of determining whether a prospect has economic potential and should proceed to development. In other words, prospect evaluation answers the fundamental questions. That is, what is the probability that the subsurface target contain economically recoverable resources? Table 2 summarizes the prospect evaluation using geophysical imaging of some natural resources depending on the resource type. Prospect evaluation assists in 1. Reduction of exploration risk. 2. Optimizes investment decision. 3. Supports sustainable resource development and enhances national economic planning. Strategic role of geophysics in prospect evaluation of natural resources. Distinguished colleagues, ladies and gentlemen, geophysics play a vital role in the evaluation and management of natural resources. Science-based subsurface exploration can drive national development, particularly in resource-rich developing nations such as Nigeria, by integrating scientific innovation with societal needs. Geophysics emerges not only as tool for exploration, but as strategic instrument for sustainable prosperity and human advancement. As a matter of fact, 20th century was dominated by hydrocarbons, which is rather depleting. essential to note that 21st century will be defined by critical minerals such as lithium, cobalt, nickel, gold, silver, diamond, rare earth minerals, iron ores of higher beneficiation standard. This implies that the global energy transition will be mineral intensive. Wind turbines, solar panels, electric vehicles, and battery storage system require unprecedented volume of metallic resources. Luckily, Nigeria is endowed geologically, if not for all of the above mineral deposits, as the country is on a lane by the following: gold-bearing schist province, Precambrian complex terrain, mineralized pegmatite province, ironstone formation, polymetallic veins, hydrocarbon and groundwater hosting sedimentary basins. However, vast areas of the country remain unexplored. Geophysics can play a crucial role in the following frameworks. Number one, in mineral resources. In mineral exploration, mining geophysics play a vital role in the location of iron bodies at silo deep depths, estimation of target geometry and tonnage, provision of information that reduce risk and drilling costs, monitoring and management of mining, and post-mining environmental hazards. In hydrocarbon exploration, the seismic reflection method is the bedrock of modern oil and gas exploration. Seismic reflection is capable of imaging the subsurface structures, that is the anticlines, faults, salt domes, identifying reservoir traps, characterizing stratigraphy and lithophases, supporting reservoir simulation and reserve estimation. In groundwater exploration, it was of noting that aquifer system are heterogeneous and in the basement complex environment discontinuous. Groundwater flow pattern are complex, most especially in basement complex areas. Contaminant flow evolve dynamically. Breakthrough time are rarely predicted accurately. Geophysical imaging is the key in groundwater investigation when it comes to mapping of aquifer geometry and boundaries, mapping of geological structures such as shared, faulted, or fractured basement zones that are favorable to groundwater accumulation and transmission. Groundwater flow pattern mapping, especially when integrated with static water level measurement. Estimation of depth to water table, most especially in sedimentary environments. Assessing salinity and delineating contamination problems when integrated with hydrochemistry. Evaluating the aquifer storage and transmissivity capacity. Electrical resistivity, electromagnetic or EM and magnetic methods are engaged for shallow and deep investigation, while the GPR method is applied for shallow subsurface characterization. Geothermal. In geothermal studies, seismic, magnetic, and magnetotelluric geophysical methods are commonly used for mapping of heat flow variations, delineation of subsurface fracture networks, characterization of hydrothermal reservoirs. At this juncture, the imaging of subsurface heart, Ladoke groundwater investigation experience. Before I go into this, we all know the importance of water to all Mancunians in terms of drinking, industrial usages, and so on. And why taking Ladoke as a case study? Because Ladoke is underlain by basement complex environment, basement complex rocks. And within these rock systems, the aquifer systems are localized. And therefore, it makes the groundwater search enormous. And we have to do it thoroughly before we can achieve anything substantive. The campus is characterized by high degree of vertical and lateral inhomogeneity. And at this juncture again, I want to let us know that the pre-degree premises of Ladoke will be used as a case study. At this premises, there are 2 boreholes that have been drilled, and the 2 boreholes failed at one time or the other. The director then, under the leadership of Professor O.S. Bello, consulted us, and later on passed the baton to Professor Giwa, and since then we have been on it. However, the leader of my department, Professor M.A. Adabenija, saddled me with the responsibility to make sure thank you, to make sure that the work is done and done very well. However, I have my reservation for the job then. I asked my Oga, where is the tool that we are going to use? He said, this is a university assignment. We have to do it. Okay. Then I sat down. How do we do this work? Okay. I decided to put student on it as a student project. And the likes of Peace Adejumobi and Damilola Olalere, I asked my Oga, give me a student, and you're blind. So we started the work. In order not to overflow the issue, this is figure 5. Please, figure 5. Yeah, this is the premises of Ladoke, Ogbomoso, and we can see that's the office of Professor Giwa. So this is the 1,500 lecture theater, and these are our lines, which we call traverses. We discovered that because of the terrain, those that cited these are the 2 failed boreholes initially drilled, and you can find out that the borehole 1 is directly on line 8. We decided to do that to know why the borehole failed. That's the first thing. And even the other one, number 2. At the end of the day, we applied 2 methods. And the first method we applied is known as 2D imaging, using dipole-dipole array. And this method is used as a reconnaissance survey. While we adopted another method called the vertical electrical sounding to confirm whatever result we obtain in 2D imaging. And these are our findings. Figure 6A. If you look at figure 6A, go back to 5, figure 5. Please. Okay. So we image according to the lines. So from this is the first traverse here, outside the gate. And the second traverse is within the premises, and so on and so forth. So figure 6A represents the image we observe along traverse 1. And if you look at it, you can see weathered basement, the topsoil, and this is the fresh rock. If you look at this place, it's as if the rock broke into two. And that is what we call basement fracture. We observe that along traverse 1. And on traverse 1, we have to place VS1 there and at VS2 here. Also, ditto on line 2. Line 2, 6B. On line 2 also, these are the fractures we obtain along line 2. This is fresh rock, where 2 borehole has been confirmed failed. Line 3, we also have fracture there. Line 3, please. This is another fracture with weathered basement along line 3. Line 4, 6D. Also, we have fractures there. Line 5, 6C. Line 6, line 7, and line 8. Now, if you look at line 8, we discovered that this is the position of the failed borehole 1. We can see it. We can see the topography here and see where the borehole was sited. Now, we were able to use VAS to confirm those points. And along figure 7, VS3, yeah, VS3 is located along traverse 2, as shown earlier. And this is the curve type we obtained here, and that is the model of that point. So, now we can conclude that from there, that VS4 seems to be VS3. That's for VS3. VS4 seems to be poorly positioned close to the edge of the fresh. So if you go back there, VS4, that's VS4. That's 6C. 6C, please. So if you look at VS4, it's at the edge of the fresh rock. And there's the need to shift the point to where we have the fracture directly. Now, on the 2D along traverse 4 seems to indicate probably fracture column between 0 and 5 stations. Hence, the VS station at station 3 is being recommended for assessment, for reassessment. VS5 along traverse 5 show prospects. That is figure 9. Figure 9. Yes. That figure. It shows prospects for shallow hole at around 40 meters. You know. Then figure 8 Figure 8. Figure 8. So that's the curve type, and this is the model. So for that point, now we can conclude from those figures. From the 2D images, the VAS model presented, their priority site for drilling are the following. Traverse 2 VS3 for deep borehole to a depth of about 120 meters. Traverse 1 VS1 at section 22. Proposed drill hole is suggested at section 23. Center of the structure on the 2D image rather than current station 22. For deep borehole also at depth of 100 to 120 meters. The failed borehole 1 is located along Traverse 8 and at around station 4.5, figure 6H. Beneath this site, the 2D image shows that the low resistivity, 84 to 103 ohm meter, weather layer of a body in blue to green color is about 30 meter thick, figure 6H. The basement bedrock shows no indication of low resistivity fracture column. This accounts for the low yield and the failed of the borehole, that is borehole 1. The subsurface sequence may also be different, may not be different at the contiguous failed borehole 2, with probably similar relatively thin overbody, just as borehole 1. The geophysics for sustainable national development. But before I go into this, I want to advise my audience. Borehole job is not a child play. And we have to, at times, consult the right hands. At the same time, we should not think that geophysicists are gods or geologists. That is, once they do the work, it's perfect. Of course, if you consult your doctor and the doctor recommend to you, go and do this, go and do that, you still take the ailment back. You not arrest the doctor. But if a geophysicist recommend, you will go to the police station to arrest. Instead of consulting the right hands, now people consult quacks. They give cheap money. We also need money. So when you consult us and we say bring 50,000, 50,000 is not too much to do the work. But when you run into issues, then you pay more than 50,000. So that's my advice. And again, our experience at the site shows that some people don't even know about the work and they make comments. Yes, that's happened to my students on the field. They will tell them, what is there? I think Professor O.S. Bello met us there sometimes. And the man asked us, so this is how you do the work. The man also dip his hand into the pocket. And he gave us 10,000 to take something that day. So these are the things we have to consider. This job is enormous and it needs experience. Having said that, geophysics for sustainable national development, the first thing you have to consider is economic growth. Natural resources can lead to economic boost when geophysical exploration techniques are effectively used. It can lead to a decrease in cost, increase in discovery rate, decline in drilling risk, enhance investment confidence. All this will result to higher revenue, job creation, and enhance national GDP. Infrastructure and engineering. Geophysics supports safe and cost-effective engineering construction by identifying faults, voids, and unstable ground that are inimical to foundation stability, detecting buried utilities and archaeological features, providing subsurface information for the design of buildings, tunnel, bridges, and dams. This will increase public safety and sustainable infrastructure investment. In environmental pollution and mitigation, geophysics aids monitoring of contaminant plumes, detection of leakages from failing dams, mapping of subsidences, e.g. landslides. Thus, it supports sustainable development goals, SDGs, such as cleaning water, SDG 6, affordable clean energy, SDG 7, and responsible consumption and production, SDG 12. Resource security. Accurate subsurface imaging leads to optimized resource extraction, reduce import and enhance export capacity, and better national planning and budgeting. In environmental protection, geophysics enables detection and monitoring of pollution, prediction of hazard, earthquake, sinkholes, better land use planning. Supporting policy and governance, reliable subsurface data supports policy formulation, regulation of resource industries, transparent licensing, and national asset valuation. Geophysics and security in warfare. Geophysics contributes to security warfare, that is warfare, through subsurface imaging of the concealed ordnance, including landmines, improvised explosive device, IEDs, bombs and bomb shells, bunkers, and so on. Naval surveillance, nuclear monitoring, and terrain analysis. It has become a strategic scientific tool that supports defense, intelligence, and post-war humanitarian operations such as landmine removals. What are the strategic vision for national development? For Nigeria and similar developing economies, the following 5 strategies are imperative. 1. National Geophysical Data Repository, a centralized digital geophysical archive is necessary. Deep exploration initiative. There is the need now to move beyond shallow artisanal exploration to deep cluster imaging. Groundwater security mapping. National aquifer vulnerability modeling is also important. Critical mineral initiative. Integrated geological geophysical targeting will bring better results. Capacity building in computational geoscience, investment in modeling, in fashion, and data science training. Conclusion. My academic journey has been guided by 3 principles: rigorous quantitative geophysical data acquisition, processing, analysis, and interpretation. Integration of across disciplines, most especially geology, physics, and civil engineering, and application of geophysics towards societal benefits. In order for sustainable development not to remain a mirage, there is the need for us to keep accurate and adequate geophysical data of our vast natural resources prevailing all over the country. Without data, there is no policy. Without science, there is no sustainable development. The future of our advancement lies not only in the skies we explore or in the technologies we invest, but in our ability to understand, explore, manage, and sustain the vast natural resources beneath our subsurface earth. As scientists, engineers, and planners investing in geophysical capacity in education, technology, and infrastructure, geophysics is not an optional but essential for national prosperity. I therefore conclude, geophysics is indispensable for imaging the subsurface as it turns uncertainty into actionable geological knowledge. Its application in national resources evaluation directly influence national economic strength and development, and so on. And so, when applied and appropriately, geophysical supports sustainable practice, environmental protection, and social welfare. Recommendations. For Ladoke to remain competitive in the 21st century, knowledge economy in order to have enough funds to cater for a myriad of financial obligations, e.g. kata. Deliberate investment in our science is not only necessary but imperative because it directly links science, natural resources, environmental management, and national development. Ladoke has the underlisted advantages if invested in Department of Earth Sciences. 1. Members of staff will henceforth produce high-impact research, attract international collaborations, and increase the university's global visibility. Since mining, oil, and environmental industries often partner with universities that have strong geoscience departments, it can lead to internship opportunity and industrial training programs for students and members of staff. Sponsoring research projects and equipment donation are possible. The university could also generate revenue through geological consultancy services, environmental impact assessment, geophysical survey, and mineral resource evaluation. The entire scientific ecosystem of the university could also be strengthened since our science naturally interacts with other departments such as civil engineering, environmental science, peer and applied physics, GIS, and remote sensing, and so on. On the final note, distinguished audience, geophysics must not remain confined to journals and conferences. It must be informed policies, protect the environment, and enhance economic resilience. The subsurface is not merely rock and fluid. It is water security. Water is life. According to Abidjan 2020, it is energy stability. It is industrial growth. It is environmental responsibility. To understand it is to secure the future. Geophysics, therefore, is not just a science of measurement. It is a science of foresight. And if we invest in it wisely, we will transform uncertainty beneath our feet into opportunities for generations to come. Appreciation. At this juncture, I want to appreciate the Vice Chancellor for the enabling environment and for allowing us this lecture. Thank you, sir. As ably represented by Professor Ebijua. I also want to thank our indefatigable Dean, Professor the thing went back because the man is great. Professor Alade, Professor Israel Alade, thank you, sir. When we are called upon for this lecture, the thing strike my mind. How are we going to do it? And the man said, there is no problem, that we can do it. And he did it. Thank you, sir. I also want to appreciate the professor, always ready, ever ready. When my name was sent to him, he called me for a meeting, and he said, Sheti Yani, go and submit your manuscript, and I did, and they started the work. Professor Latif Agbaje, thank you very much, and your teams. I appreciate Ogbomoso, Dr. Gio Ogbomoso. Dr. Gio Ogbomoso gave me some of these pictures used here. Other members of the team, of the committee, I appreciate you, Professor Mrs. Ibrahim. Thank you very much. And others, because of our time, I want to appreciate my immediate constituency. Department of Earth Sciences. I wish to appreciate our indefatigable leader. I call him the leader of the house, Grandpa Professor Emi Adabanija. Thank you. Thank you. He actually pushed me into that work, the work that was presented here. And he said, the way you are going to do it, I don't know. Just go and do it. And it has been done. Thank you, sir. I also want to appreciate second in Calabash in the department. Second Calabash. We call her Grandma, Professor Mrs. Adewaye. Thank you. I appreciate you. Thank you. I appreciate all my colleagues, the HOD for today, the Alifa of the universe, Dr. M.T. Jima. Thank you. Dr. Oye Afolabi. Thank you very much. The list is endless. The list is endless. I have other people there. Mrs. Isaac is here. DDMOS, she's here. Sorry, Professor Akilabi. Sorry. I'm very sorry for that. Please. Sorry for the oversight. And finally, my indefatigable EO, Mrs. Oyebode. Thank you very much. She's been so supportive. She's been so supportive. And my team will attest to that. She's so supportive. I want to thank all the members of staff in the department and the faculty of Pure and Applied Sciences. I HODs, thank you. My DD, thank you. And all others, non-teaching members, I appreciate you in our department and other departments. Thank you very much. I will not forget our elders, our leaders in the department, in the faculty. Professor Ladoke, thank you very much, sir. Professor Ogukule, thank you. Professor Fawole, Baba Aron Baba, thank you. Professor Simonu, thank you very much, sir. I appreciate you, sir. Finally, my family, my wife is not here for a reason, but represented by our first son, Emmanuel Anoluwapo. Thank you very much. I want to tell you that he did some of these drawings, although we fought during the process. Thank you very much. Finally, our students. I appreciate you. Our students, thank you very much. My advice to you, you must submit yourself to learning. You must learn well. If you don't learn well, there's no way out. I wish you well your future endeavor. Thank you. Finally, something was whispered into my hearing. I'm very sorry. My former dean, Professor E.T. Ayodele, I appreciate you, sir. Thank you, sir. On the final note, member of the crew, photographers, the media, and all that, I appreciate you. I want to also appreciate somebody. That's my professor, Professor M.O. Olorunfemi. He has been with me since I got to this school, and I've also always been under his tutelage. That's why I told my students, even at professor level, we are still learning. So you must learn. My professor edited the manuscript and suggested he suggested corrections where necessary. So I appreciate him. Although he's not here, but I appreciate him. May God bless him abundantly. Thank you very much. Please permit me to introduce somebody, please. And that is my teacher in primary 6. Mr. Kayode Ariade Adeshina is in our midst here. Please. Thank you very much, sir.
Please, shall we be seated, please? We want to appreciate the lecturer for that beautiful lecture. So without wasting much of our time, I want to invite the Vice Chancellor, he'll be represented here, for his remark. The Vice Chancellor, sir. A round of applause for him as he comes to the podium, please.
The Dean, Faculty of Pure and Applied Sciences, Deputy Dean, Faculty of Pure and Applied Sciences, distinguished professors in the faculty, heads of departments, I bring greetings from the Vice Chancellor, Professor Rom Kalilu. Professor O.O. Vawole, you are welcome, sir. I am glad to be here today to represent the Vice Chancellor. I'm equally happy that the Faculty of Pure and Applied Sciences is doing very, very well. I am happy with the depth of research from what we have been seeing from the faculty lecture and the Faculty of Pure and Applied Sciences. And I'm indeed satisfied, especially with the presentation and the mastery, the way you have explained everything about your geophysics. And I want to make a suggestion, just like what we have done in the Faculty of Arts and Social Sciences. All your presentations, all the presentations this far could be put in a book form such that we don't miss out some of these ideas, wonderful ideas that can be looked into in the future. Most of the earlier presentations, and I'm sure some of us must have lost the ideas that were in there in the earlier presentation, especially the first 8 or 9 presentations of the faculty. If we have them in book format, it will give us a better way of looking at it. Now, most of us that are novice in geological research, from what we have seen now, is a gold mine. Minerals under the surface are gold mines that government should research on, and that will increase our revenue at different levels, both at the national and at the state level. I also want to believe that the Department of Geology is just like we used to have in the days past, Aki Consults. Those of us from architecture, you must have heard about Aki Consult. There could be something like Geology Consult, where you could provide services to the university and provide services outside, because you have the requisite experts in the department and the faculty. So in rounding up, so that I don't waste our time, all you have said, the presenter, concerning the Vice Chancellor, I will deliver your message and to ensure that he reads your recommendation and make do with what you have there. I want to thank the organizers again, Professor Agbaje Latif, for a wonderful job, especially your team. I'm happy that you are supporting our Dean I will pray that you continue to do so. I'm calling him our dean because we are a product of that faculty, and they will still remain our dean. Whoever is there will remain our dean. I thank you all. May God continue to lift the faculty and lift the university and Oyo State government. God bless us all.
Thank you very much, sir, the Vice Chancellor. Please let me quickly recognize our HOD, the HODs in the faculty, and I'm going to start with Professor A.A. Ayendele from the Pure and Applied Biology. Thank you very much. We have Professor J.A. Badmos, Biochemistry. Thank you very much, sir. We have Professor O.S. Amuda, Pure and Applied Chemistry. We have Professor O. Olabisi, Science Lab Technology, SLT. Thank you. We have Professor O. G. Bayowa, Art Science. Okay, our lecturer. Dr. A.S. Adewumi, Pure and Applied Physics. Dr. O.A. Adepoju, Acting Head, Pure and Applied Mathematics. And Dr. O.A. Adeshina, Acting Head, Statistics. Thank you very much. We appreciate you. And I won't also forget from my own constituency, the faculty officer, Mr. Ariel Ogukuni. Thank you very much for coming. Now I want to specially recognize in our midst, though he has been recognized, but especially now, Professor O. Fawoli. Thank you very much, sir. We appreciate you, sir, for coming. Now I'm going to call on the dean again to come and declare this lecture closed. But before then, please, the members of the high table, I want you to come here, sir and ma, for photograph. All other photographs will be outside. But for the members of the high table, we are going to do it here.
Thank you for your rapid attention. On this note, the 11th Fpas lecture series is hereby declared closed. Thank you.
Photographs. Please, the program is still on. We are not. Please, let's be seated, please. Let's be seated, please. Students, let's be seated, please. Here, sir. Paul, sorry, Yarada. Send it. Send it. Thank you very much. Shall we rise for our anthems, please? While still standing.